Hi, everyone. This is Don Gillis, and you're in for another chill zone, condensing the facts with myself. Today, we're going to talk about proper installation, and we're going to go for it. We're going to have three poll questions as we move along, and then we'll pick someone out for a pizza. Uh, Winner of the pizza supply. I think Chris is going to do that. And I apologize. I think we lost Chris. So again, without further ado, let's go over here.
I just got back on. I apologize. Yeah, I did get lost for a sec, but no worries. I am here.
Okay. Did you have anything you wanted to say, Chris, prior to?
I was just going through the introduction real quick. I just wanted to make sure that everybody knows how appreciative we are that you're here joining us today. We know that y'all have a lot of things going on. You got customers sitting at the counter, all kinds of stuff. So we do appreciate your time here today. If you guys do have any questions, feel free to type them down in the chat box below. We're going to make sure that we go through as many as we can, even if it means going a little long. And then at the same time, we're also going to have some questions for you guys. So once in a while, we're going to throw up some poll questions just because it helps us understand what you guys are seeing in the field. So all kinds of stuff. And then later on today in the program, we're going to talk about pizza. But really, we're all just here to kind of listen to Don and have him just compress as much of this information as he can into our heads so that we're ready for our customers when our customers come walking in and ask us basic questions. So thanks for everything. Thanks for listening. Take it away, Don.
Okay. Hey, thanks a lot, Chris. So real quick here, the first part we're going to talk about is what's not changing. We always talk about what's changing. The second part is going to be what is changing. And then third will be need to know, will we need to change our line sets and things like that. And fourth will be working with refrigerants and oils. That's going to go pretty quick. And then the last or the fifth one is going to be A2L compressor fundamentals. We're going to talk a little bit about what's changing. Now, I can't speak for the compressor manufacturer or equipment manufacturer, but I do know a couple things, and we'll talk about those. Last but not least is going to be repairing, servicing, and when to replace equipment. We're going to talk a little bit about reclamation also, a recovering refrigerant. All right, so let's go. So what's not changing? As of today, okay, you will be grandfathered in with your EPA 608. Moving forward, you'll see those questions as we did with 410A on A2Ls on the new test. So as of today, there's nothing federally or state recognized as far as an A2L certification. I want to be clear about that because as Chemours does, there's a lot of folks out there giving certifications. Those are certifications that are recognized by that organization, okay? It just means that you've done some A2L training. I've heard say that some people need that proof in whatever municipality or state they might be in. So check with your manufacturers. Do they want you to be A2L certified? Check with your wholesalers, distributors before they sell you refrigerant. Do they want you to be A2L certified? But as of now, EPA does not require that. What's changing your truck? Not a bunch. In fact, nothing at all, to be honest with you. In fact, all the safety things that we see now on the screen will stay the same, including the Class B fire extinguisher. So that'll all stay the same. What else is not changing? Well, the second law of thermodynamics. It sounds easy, but what is it really telling us? In very simple forms, because I don't like big words, hot goes to cold, high pressure goes to low pressure, and if you're into IAQ, wet goes to dry. It's pretty simple, okay? And some people would argue that hot's really an opinion, but anyways, warm goes to cool, and high pressure goes to low pressure. And the reason I point that out too is the system, the DX system from an HFC to an HFO or an HFO blend is going to stay the same. So we're still going to be dropping our pressure there at our TXV, our pressure dropper, if you will. When we drop the pressure, we drop the temperature. And when we drop this temperature, we're primarily liquid, 75%, 50%, 25%. And our heat from our load, whether that be residential or commercial, is coming through there. And that liquid or that saturation is picking that heat up. Okay, hence the reason we call this superheat over here. It's been superheated. As we move through the coil, we're not really making anything cold, we're removing heat. Okay, and that's what we are. We're heat movers. As we come down the suction line, the idea there is to be all vapor or superheated vapor, or we hear crunchy noises in our compressor. Okay, this bulb, as you know, is full of refrigerant. Okay, it may be the same refrigerant that's used in the system. They do not interact with each other. More than likely, it is the same refrigerant, and it's based on pressure temperature also. As it gets warmer, it gets a higher pressure, pushes down this hole in this tube, and then opens up the diaphragm and asks for more refrigerant, okay? So as we pick up that heat here, if someone would ask you for superheat as it's an equipment designer, just a fun fact there, they're going to be asking you for the superheat here. They want to make sure that that TXV is matching the load. As we come down the suction line, we're picking up more superheat. If a compressor manufacturer asks you what your superheat, they're asking you what's entering the compressor, often referred to as total superheat. The first job of this suction line here, this cool superheated vapor, is to cool the motor of the compressor. 99.9% of the compressors out there are refrigerant cooled. The next part of it's going to be compressing those molecules. As we compress those molecules, they start to move really fast and they get hot, which raises the pressure up it. And if you've ever touched the top of the scroll compressor after it's been running, you typically don't do it twice. And we raise that pressure to raise that temperature. Now we coming out in the discharge line, it is also superheated vapor, but now it's high pressure superheated vapor as opposed to over here in the suction line. Okay, and we move forward, we come up the discharge line, we've got our outdoor unit, air conditioning, heat pump, whatever the case may be. We're in air conditioning mode. That air is going to come across those coils and it's going to reject outside the fan where the fan is on top of it. Now we're rejecting a lot of different heat there. Okay, we're rejecting the heat from the load, the heat from the superheat, the heat from the motor, and the heat of compression. So we refer to that as de-superheating. As we come through here, vapor will enter this coil at the top because it's lighter than liquid. As we start to remove that heat from there, it starts to condense, okay? Hence the name condenser. Okay, and then we go into our liquid line, which is smaller because now the refrigerant's condensed. It takes up less space than the vapor. Come on back down the liquid line and start the process all over. So our two key points here is we're dropping pressure and we're raising pressure. That's the purpose of a DX system. That's the philosophy or the science behind it, if you will. We've got a poll question already. Chris?
All righty, guys, poll time. All righty, quick question. Will you need to be recertified by the EPA to work with A2L refrigerants? So we did just talk about it real quick, but this also kind of expands out, not just with HVAC. This question goes out with ComRef as well, right? So is the EPA going to require that you're recertified to work with these refrigerants? Just a yes or a no. Let's see if we can watch how these polls are coming in. Well, you seem to be a very good teacher, Don Gillis. 100%, I'm saying no, 100%.
Yeah, well, very good, everyone. So at least we got that through and everyone knows, because there is a big misconception out there about that, believe it or not. So thanks, Chris, I appreciate it.
Of course.
What is changing? So what is changing? First of all, you will not be able to put A2L refrigerants in an existing system. A2L refrigerants will only be used in new equipment, whether it's HVAC or commercial or whatever, okay? They're not designed for it. There is no retrofit kit at this time, so be aware of that, all right? Before installing a service in A2L equipment, this comes right off of AHRI's Safety and Handling Task Force for A2Ls on their website. Safety first. As always, we're going to read the manual. Read the manual. Follow lockout tagout procedures when needed. Verify there's no voltage present before working, okay? And that's been something that's been around forever, okay? And in fact, all these first five bullet points are pretty much the same as it was. Ensure the area is well ventilated. Evaluate the work area. What do you mean by that, Don? Make sure there's no ignition sources, flammable vapors, confined spaces, and look for a clear exit point. Now, I know that sounds like a lot more so than what we did in the past, but quite honestly, this is stuff we've always done when we're working with refrigerants. You know, in some cases, we've had to use ventilation in past histories with just A1s, whatever you're using. Now, there is the big change here is, the biggest one for me is at this time, at this time. It's not required, but it's recommended to have a 10-foot work perimeter. Okay, and if you want to search that out, it's in 2-40, UL 2-40, pardon me. And UL makes the standards for the safety of the equipment. ASHRAE is the safety of the installation. So if you want to find that, it's in Annex HHH. It mentions that, and at this time, it is not required. So something required would be a good visual there would be like a utility company out on a corner with a bunch of orange cones or yellow tape. That's required by the state. At this time, this is not. So don't have Joe or Julie out there smoking, just obvious common sense things like that. Using procedures, new install. We're still using ACR. It's seamless dehydrated and it's measured in OD, unlike plumbing that's measured in ID, okay? So use the correct size. Cut with the proper tools when deburring as required. So don't use a Sawzall. Those little burrs out there, make sure they don't fall inside the copper. Those end up on your windings on your motor, and it doesn't happen right away. It happens, takes a little time. If you're using flux, and I don't mean what's in your brazing rods, be very careful. Just like moisture, that's acidic, okay? And you ensure proper fit and fastening as required. Follow all codes if you're licensed, and select proper heat source, whether that be acetylene or acetylene and oxygen. I prefer the acetylene oxygen. It gets hotter, it gets quicker. Acetylene's fine, it's lighter, it's easier to carry up those 40-foot extension ladders. And then one other thing I wanted to share with you here about brazing. When I was taught brazing, kind of like what this torch is right here, it's heating up that female fitting. But since they changed that material to a copper-clad steel and not pure copper anymore, if you're using like a torch like acetylene and you stay on there a very long time and get it like cherry red, something you can share with the contractors. It's just a film around there, that copper clad steel is. If you eat that away, it's solid steel. And I've done it twice in my life and it's a very long day. So we're going to use conductive heat, one of the 3 heats we were taught in HVAC in our early career. And we're going to heat out here first to warm that pipe up. And then we're going to come in a little closer at the second. And then last but not least, we'll come in with that 3rd arrow. And then by the time we get there, we're staying on there very little because it's already warm enough to suck that brazing rod in. There's actually a bulletin. I'm going to show you that right over here on the right-hand side that does that actually tells you more about that. I refer to it as the 1, 2, 3 step. Okay, so just fun fact there on that. And then we're going to purge with nitrogen or inert gas, nitrogen in most cases for that. Why do we purge with the nitrogen? This is why we purge with the nitrogen. This is an actual picture of something I did 6 years ago at my previous job. And on the left-hand side, I went into the lab in the summertime when we were slow, and I brazed without nitrogen on the left-hand side and with nitrogen on the right-hand side. You can see the outcome here. And the ashes that you're looking at there, gang, is actually from inside. We always see this on the outside, but it was really surprised when Corey opened this up for me in the labs and cut it open, and this fell out, even for as long as I've been doing it. The thing about this is POE oil really changed the world. It's very hygroscopic, it absorbs moisture really well, and it's very polar. Okay, it will make this look like this in a very little time. And this stuff here normally ends up in your TXV, okay? And that's when we think we have a bad TXV, when in fact we just use bad installation practice. And I'm as guilty as anyone, just so you know, okay? When we're purging with nitrogen, some of the facts that we need to do, we need to protect the components with a wet cloth or while brazing. They have a lot of products out there. I'm sure you know this better than I do, things like wet rag. I just gave some samples out there. Always remove your Schrader cores to make sure you don't melt those O-rings in there. Hook hoses up. Set the regulator for less than a pound. So if you look over here, basically all you're doing, you're not pressurizing that line. I know I'm preaching to the choir here, but just to share this with your technicians at the counter, we're bleeding that through less than a pound. We're not setting it for purge. That's to remove residual refrigerant, and we'll get into that a little bit later. And then taking your Schrader valves and just letting that bleed through there ever so slightly. Don't need a lot. Okay, you want to make sure you're still pulling in that brazing rods and then bleed the nitrogen through. Okay. When install a liquid line filter dryer. Now I know you're thinking, why do we need to do this? When we went to POE oil, I always used, the person I worked for encouraged me to put, or required us to put, a liquid line filter dryer. And the purpose of a liquid line filter dryer is to mainly move moisture. It's 75% of it's molecular sieve, 25% of it is activated aluminum that moves acid. When it comes to suction line filter dryers, it's flip-flop completely. So when will we change a liquid line filter dryer, Don? Well, anytime we open the system, okay? Anytime you open a system, you are required, or supposed to, good practice is to remove that and move it in and change the new one. Anytime you have a pressure or temperature drop, and when we're looking at pressures, if you can put a pressure, if there's some kind of Schrader port here, we're looking at somewhere around 3 pounds or so or more. We want to change that out. If it's frosting up, obviously we have a restriction there. Temperature drops about the same thing, 2 or 3 degrees, we want to change this out, okay? Now I know this is a flared fitting here, but if this was a sweated fitting, a sweat type of liquid line filter dryer, we want to cut them out, don't sweat them out, okay? The reason for that is when we add heat to this, to the moisture, we get steam, which just pushes the moisture back in the system before you get the old one out, only to be caught again by the new liquid line filter dryer. So be careful with that. Cut them out, don't. Field and pressure test the components. That's always been done, okay? It's always been good practice. You're going to test the low and the high sides. And then the biggest one here for me is the third bullet point. The reason I have it in bold-faced letters is pressurize and hold for 60 minutes. This is now a requirement, okay? Before this, at least under the IMC, which I'm licensed under, we've never had a set time. So we have to hold that, put the pressure, whatever the manufacturer says, and hold that for 60 minutes, okay, or 1 hour. And obviously don't exceed the data plate. When in doubt, if there's no data plate on there and it's an old system, never go over 100 pounds, because those systems didn't go very high with pressure, especially on refrigeration systems. The system shall show no loss of pressure in the measuring device during the test. And then if the OEM specified pressure should drop, we're going to perform a leak test. We're going to want you to record that pressurized inside the equipment, label that, where we used to put it on our invoices and stuff like that. We want to document that and leave that for proof on either in the manual or inside the door of the new equipment. That's in UL 2-40. Okay, so, and some of the things we're going to look for as far as leaks doesn't change at all. Soap bubbles, electronic, ultrasonic is for sound. It's not really that great for mechanical rooms. It's with headphones and what have you. When we use electronic, keep in mind, I know I'm preaching to the choir here, but some folks don't think about this. Well, you can't just use nitrogen. You got to put a little trace of refrigerant in there and set that in there for it to find the leak, okay? System evacuation, removing non-condensables. Not a lot of changing here, but take a look at it. Use proper vacuum pump. There is a scale or a mathematical formula that you can use. Quite honestly, more importantly than anything, change your vacuum pump oil. Okay, 7 CFM pump will cover about everything out there, almost 90% of the stuff out there. So I don't get really hung up on the size of the pump, because quite honestly, a 1 CFM pump will pull a system down to 500 microns. It may take a week, but it'll pull it down. Okay, use a calibrated micron gauge. They sell those stuff. You sell those stuff at your counters there. When in doubt, you can use rubbing alcohol or good old brake fluid is something I've always used in the past. And then the accepted industry standard for quality deep vacuum has always been, for the EPA standards, 500 microns or less, 500 microns or less. You need to hold that vacuum and then refer back to your local jurisdiction, because at the end of the day, if you're not under any kind of codes or anything like that, the local jurisdiction is going to have the final say. You're going to record that on your equipment label. That's in UL 2-40, date, pressure test, and the vacuum. You're going to see a lot of decals inside the equipment door if you haven't already seen it. Okay, using a 2-stage vacuum pump, real quick, just some fun facts here. Occasionally, I'm going to suggest performing a blank off. A blank off simply means you're hooking your micron gauge directly up to your vacuum pump, and you should be able to pull down to at least 100 microns. Okay, open your ballast when starting up. You see most of those the fumes and vapors and stuff at the very beginning. We start to pull down, and then you hear that motor of that two-stage vacuum change speeds or change sounds. That's when it starts to drop even lower. Primarily, most of those non-condensables and moisture are moving literally within the first 15 seconds. So by opening the ballast on your system counterclockwise, it's like a vein you're opening up. It bypasses and introduces dry air, which helps it not condense with those pistons in that motor and drop that moisture down into the oil, okay? Some manufacturers say when it gets to 3,000 microns, drops down, shut it off. Some folks say 10, 12, 15. Check with your manufacturer on your vacuum pump. The moral of the story is start to shut it down and then monitor your pull down as usual, okay? This just happens to be a document to the right-hand side I wrote years ago, okay? Keep in mind, every hash mark, if they're not using micron gauges, this is a fun fact, if they're still using compound gauges, a compound gauge will not pull down and tell you how tight the system is and how much moisture is in there, okay? And close doesn't count when it comes to moisture, all right? Every hash mark in here, okay, I blew this up, is about 2 inches of mercury, okay? 2 inches of mercury column is about the equivalent of 50,800 microns. And we said we wanted to be at what? 500 microns or less. So again, close does not count. There's still a lot of moisture in there, all right? To give you an example here, on the face of the earth, we boil moisture or water at 212 degrees. We have 760,000 microns. Our gauges are zeroed out. I'm going to move down to 50,000 just because that's what almost it was for those little hash marks of the equivalence of between. Our gauges are reading somewhere between minus 2795, and we're boiling water at 101. At 500 microns, the significance of 500 microns is we're almost close to that minus 30 that we all said, hey, let's get out of here. That's utopia. It's a perfect world. We're actually boiling that moisture in that system at minus 12 degrees, okay? So by pulling that down, we're changing that pressure, that atmospheric pressure, if you will, or inside there, and that pulling it down less than atmospheric pressure, and we're boiling water less than 212 degrees. Now we're at minus 12, so we're getting all that moisture out. So Don, why the 500 microns? So we didn't just pluck that out of the sky. They discovered at 500 microns or less, we proved that the system's not only tight, but it's dry. If it starts to creep up above that, 1,000 microns or so, the vacuum is still tight, but there's moisture in there, okay? So when that starts to creep up a little bit, as you all probably know, it's not the end of the world. We just pull another vac down, kick it back on. We might have found some moisture in the oil somewhere. Now, if it keeps creeping up and going up on you, then we got to start looking for a leak, okay? Poll question time, Chris.
All righty, let's get to it. Next question is, when testing an A2L refrigerant line set, you must hold that pressure for a minimum of how long? All right, this is a really cool question. We were just talking about pulling a vacuum. Next, we're going to be talking about pressurizing it, right? Talking about the line sets that you guys have running from the outdoor units to the indoor units. How long do you need to hold a pressure test for? 30 minutes, 60 minutes, or 90 minutes? And let's see how we're doing with responses. But this is a different kind of crowd today, Don. We've got 100% going with 60 minutes. I've never seen 100% coming out of these polls.
Yeah, it's yeah, for sure. That's great. That's awesome. I love it. Yeah, good for you. Yeah, somehow my webcam. How many people answered the question?
Oh, let's take a quick look. Half the group voted.
Okay, good.
So I guess we got 27 people on the line, and so half of those.
Awesome. Awesome. Very good. All right. Okay. Can you hear me, Chris?
Yes, sir.
Yes.
Okay. Moving on. Sorry about that, gang. Somehow my audio and everything changed on me. Okay. Pizza. Chill Zone Pizza Party. Yeah.
Oh, nice. Excellent. All right, guys.
Yeah.
Real quick. Okay, so wanted to congratulate Lauren Jett, who was last month's winner. The pizza party went off, seemed to be swimmingly well. She's over in Newport News with her group. And let's see, so we've got JB Boudreau from back in September and Steve Wilson in August. And now for November, we've got the November winner. We went through our random name picker, and it's Mr. Nick Markle out of Our Steel. So Our Steel, I think they're up in the Midwest,
Yes,
Wisconsin, that kind of thing. And Nick Markle's our winner.
Yeah, yeah.
Good deal. Absolutely. So congratulations to Nick. And Nick, you're looking for an email from me, okay?
Congratulations, Nick. Thanks, Chris. I appreciate it. Wow, 3 pizzas. Did we bump that up? Hey, will we need to change line sets? The answer is yes and no, okay? So if it's the same size as the line sets are for the new equipment, you can keep them in there, okay? Now, what they're gonna want you to do is prove, okay, that on the new installations, it's required in 15, which is commercial, 15.2, which is residential, that you need to use striker plates if it's within 1.5 inches from the wall before the drywall or the whatever that wall surface is, okay? And this has been around for years. Under the IMC, which I'm licensed under, this has always been around. And throughout my travels throughout the nation, most people are already aware of this, okay? But moving forward on the A2L refrigerants, not just plumbing. So, and most people identify this as a plumbing thing with copper lines. You need to use these, what I call striker plates. I've heard them called nail guards, whatever that is. It's about an 1/8 inch piece of steel. So when Mrs. Jones or Mr. Wilson comes along and tries to drive a nail through here or a screw, they're not going to know why they're striking into something. It's just not going to go in, okay? So moving forward, now on existing systems, they're going to ask you if you can't prove that that nail guard is in there, which is going to be hard sometimes, obviously. They want you to pressurize that line, and again, they want you to hold that for 60 minutes, okay? All right, so that's something you have to document that, all right? Now, when we talk about line sets, real quick here, there's 2 reasons we size line sets or use size line sets for what you sell to the contractor. And that's velocity and volume, okay? So if in the volume, if the line isn't long enough, let's say this suction line, for example, if it's too big, it's got enough volume to cool that motor on that compressor, but it doesn't have enough velocity to bring the oil back, okay? And if we were looking at the liquid line, if that was too small, okay, it's restricting that, can't bring the velocity back to the oil, and the TXV, quite honestly, is irrelevant at this point because the system is designed to have that pressure drop exactly across that TXV. So if we've got this pinched or we've got this too small or kinked or whatever, so it's volume and velocity, okay? I always encourage contractors, don't argue with the people at the counter, okay? If they say it's got to be 7/8 and 3/8, that's what it's got to be. Don't go to 3/4 just to save a buck because you will pay for it at the end. All right. Working with refrigerant oils, quite simply, POE oil again changed our industry. We didn't know a lot about it, and some of the characteristics of that is it's very hygroscopic. Okay, so it absorbs moisture very, very well, and it's an organic form. The main process is removing that moisture. Again, it acts as a polar agent. Pardon me. I don't want to make it out to be RX11, but it's pretty darn good. It acts as a solvent and will wash away there. Unique additives for proper design. And then last but not least, it will hydrolyze in the presence of water, which simply means it breaks down in water. A2L compressor fundamentals. Let's talk about some of the changes. So if you have someone come to the counter and say, well, can I just use this 410A or this R32? No, there's differences. The R32, or let's start with the 410A. It's an A1 compressor designed for 410A, okay? 454B will have its own model number. Let's talk about Copeland or any of their competitors. And the reason for that is different pieces, different materials because of the possibility of the HFO refrigerant acting differently in there. It's classified as an A2L. The biggest thing you're going to see is the thing outside the compressor and the way they're casing those electronics. Again, this is all UL required, okay? And when it comes to the R32, it's an A2L compressor like 454B, but that POE oil is going to be different. It's going to be a POE 46. So 410A is a POE 32, 454B is a POE 32 also, and then R32 will be a POE 46, but they're all different in each one of their ways, so be aware of that. Speaking of A2L components and things like that, like I said, you're going to see some difference internally. You won't see them actually, but the bearings have been changed, things we call like the Oldham coupling, for those of you that see me tear compressors down in the past. This bottom orbiting scroll will be different. And then one last thing, I want to talk just a little bit about the importance of compression ratio, because the number one reason A1 and A2L compressors will fail is overheat. And the number one reason for overheat is compression ratio, and that's simply saying this. Okay, either the head pressure is too high, the suction pressure is too low, or both. Okay, and that can be either way. All right. So I'm going to turn my camera off there. So giving you some examples here. So let's talk about this right now. Standard atmospheric pressure we say is 14.7. Okay, and when we talk about how to calculate compression ratio, is quite simple. All we're doing is taking whatever's on your gauge, okay, whatever it reads on your gauge. And in this application, you can see I'm using a low pressure or a freezer type application, -35 on the EVAP or SST. Okay, so my high side's 185, my low side is 5. I'm going to then add 15. The 15 comes from the 14.7. I'm just simply rounding up just to make it easy math. We're then going to add that to it. We get 200 over 20. We're going to divide that 20 into the 200, okay? Whatever you get put out of that answer, put it in front of 1. Whether it's 5, 6, 7, put it in front of 1. That's your compression ratio. These are good numbers. If you're working with air conditioning, we often refer to that as high temperature. It's about a 3 to 1. Medium temperature, you're reaching coolers, Bloney, beer, pop, it's going to be about 5 to 1. Your low temperature freezer application is going to be somewhere around 10 to 1, okay? The higher that compression ratio goes, the harder that compressor is working. So if you walk up to an air conditioning system, for example, let's use that, and you're reading 10 to 1, you're probably not seeing 225 degrees 6 inches out from the compressor, all right? You're probably reading really hot. So if you know what the temperature should be leaving the compressor, and you know what the compression ratio is entering the compressor, you just kind of made that compressor, let's say, plexiglass. I mean, you just told yourself a lot about that system. So just a fun fact there on that. We have a chill zone pull time. Chris?
All right, sounds good. Let's have it come on up. Okay, according to the EPA, a refrigerant line should be pulled down to a vacuum level of what? So what's the micron level that we should be pulling it down to? Is it 500 microns or less, or is it more than 500 microns? Let's see. All right, let's see how people are answering. All right, so we did start talking about that a little bit. The micron gauge. I love that. Was new information for me, Don. The hash marks on the gauge is 50,000 microns, and it's really interesting to see that you really do need digital tools for that.
Absolutely. Okay. So a good encouragement to I don't know if I want to say upsell, but to get those micro gauges in those folks' hands out in the field. So thanks, Chris. A2L repairing service and when replacing. We're in the down stretch now. We're going to talk about recovery first, okay? Obviously, we walk up to a system. We're changing the system out to 410A. I had the luxury of the benefit of doing this a couple months ago. I actually tore out a 410A system and installed an A2L system. The joke there is I installed an A2L system and lived to talk about it. So step one, recovering that refrigerant. Notice the red stripe around the recovery tanks. That's what's going to be coming on the recovery tanks, just as if you will see the A2L tanks. Always use proper PPE and lockout, tag out if not needed. Again, you're going to have that 10-foot radius recommended at this time. Please don't make that required moving forward. Be safe. And quite honestly, this is stuff we've always done. Look around, make sure everything's safe there. You know, when you're on a job site, a commercial job site, when OSHA's on the site, we don't want splice cords and things like that. It's the same concept. And obviously, never vent refrigerant. It's in your EPA. Pull a vacuum on the recovery tank. You want to remove that moisture even from a new recovery tank. If you didn't know that, pull that down to and the number there too is, if you don't know, is going to be 500 microns or less. By the way, okay. So we want to pull that down, even if it's a new tank. Use only A2L recovery cylinders and never mix A2Ls with A1 refrigerants. All tools should be rated for A2Ls moving forward. Okay, it doesn't mean everything in your truck is not A2L. Check with your manufacturer or check with your wholesaler. Use liquid line filter dryer, as we talked about. In this case, I threw this in as a recommendation to put it prior to your recovery tank. I lost a couple recovery tanks or recovery machines early in my career and was a little baffled by it. And it's the same as anything else, like a system with a motor. Okay, that moisture gets in there and prematurely breaks it. All right, so you always want to put a liquid line filter dryer in line going into the recovery machine. Recover all refrigerant before opening the system. Don't exceed the cylinder fill weight. And for those of you at home, you already know where I'm headed with this. Good practice has always been never exceed 80% liquid. Okay, we allow for that expansion on that tank there. Okay, label recovery cylinder, what's in the contents, and then, oops, my bad. I want to go back here. Just one thing. You'll see things on the collar. If you're sharing this with others, we've got a TW, that simply means tera weight. Tera weight simply telling you the weight of the tank. So you take the weight of the tank and you put the gas in there, and then you reweigh the tank, and now you know how many pounds of refrigerant you took out from the system. The WC is for water capacity, because a gallon of water doesn't weigh what a gallon of milk weighs, right? And then I've got date on there, a little fun fact on there if you don't know. It's on the EPA test in your 608. But these need to be turned in every 5 years. So whatever the date says, if it's beyond that 5 years, you need to turn those in. We always want to look for rust and any kind of wear and tear on the outside of the tank too. That's always been good practice. All right. So recover, recycle, reclaim. I want to go over these real quick, even though I'm preaching to the choir again. Recovery, we recover the refrigerant from that property at Mr. Smith's house. Okay. That is Mr. Smith's refrigerant. But let's say it's Mr. Smith's rental properties, okay? That's his refrigerant wherever he owns properties. So it could be on Vine Street, and you can recover that and move it over to Maple Street, as long as that's still Mr. Smith rental properties. If you take it from a Walmart on the south side of town, you can put it in the Walmart on the north side of town, okay? Recover it. The recovery, whoever owns that equipment owns the refrigerant, but not necessarily has to go back on that property, okay? It's the owner of the equipment. Recycle is exactly like recover, except you took an extra step, maybe a liquid line filter dryer, some way to clean that up a little bit, maybe remove some particles, but not up to the standard of purity of like we buy R22 today. Reclaim is just what it says. You went to the full circle here, you brought it back to reclaiming company or a wholesaler, and it was reclaimed back to AHRI standard 700 for purity specifications, like virgin refrigerant is. And that's how we buy R22 today. Okay, always follow manufacturer's literature. Use inert gas when remove any residual refrigerants. Okay, this has always been good practice. Okay, now it's going to be required for A2L refrigerants. In other words, when you cut that line open, okay, you, just like we had our nitrogen out earlier to braze with, okay, we're going to put that on the line there. That's what the purge setting is for on your regulator there, in case you didn't know that. I know the folks at the distributors know this, but share that with your customers, okay, because a lot of folks don't know that. We want to blow that residual refrigerant out of the A2L. You know, a lot of folks think when you put our torches down there, including me, by the way, when we cut those lines open, we go to repair, we see that little lazy flame or that little bit of flame there, like a candle, if you will. I always thought that was oil, but no, that's, in fact, that is residual refrigerant from an A1 refrigerant. So just a fun fact about that. Moving forward, it's going to be required. It's always been recommended. It's always been good practice, okay? Ensure equipment's grounded. Use a proper capacity discharge method, whatever that looks like to you. Use only OEM approved A2L replacement parts. That's key. When we're working on new A2L equipment, you only can put the A2L approved OEM part back in, okay? That's going to be a staple. Install the new liquid line filter dryer, as we talked about. Use nitrogen before and during brazing. And when people, you know, argue and say, hey, I just, it's such a hassle getting all this nitrogen. If you think about it in the long run, okay, you're going to get the nitrogen out to pressurize the line anyways. You should have the nitrogen out when you're brazing. And that makes it easy to make the reason for the argument of having it out to remove the residual, because you're only going to get it out one time, but you're going to use it 3 times. So just get it out and use it for all 3 of those. Remove the residual, okay? You're gonna pressurize your line. You're gonna use it for brazing, so just keep it out. All right. Recharge the system by weighing in the charge. Document that information inside the equipment door. Always leave the installation manual out. In closing, let's talk about charging the A2L system. There's not a big wow factor here. We're still going to do the same things. Again, recommended that 10-foot work area, safe work area. All right. Charge blend refrigerants in a liquid state. Any blend refrigerant, we always want to have the tank upside down. We all know that. All right. Calculate your weigh-in charge. What do I mean by that? Typically, and I'm just ballparking this from my experience. Let's say this outdoor or air conditioning shows up. Let's say it comes with 15 foot of charge. That's 15 foot of charge of 15 foot of line set. That also is for the evaporator. Anything beyond that, you have to have a multiplier. So we're going to start that charge on our suction side before we release that refrigerant or turn the equipment on. We want to load up on the liquid line. We don't want to load up on the suction line because we don't want to slug that compressor. All right, the initial startup. Then when we start up, we want to verify the airflow and then liquid charge on the suction service port and be very, very careful there. All right, we want to goose it or throttle it just a little bit to dial that in. Okay, and then beyond that, we want to start our othering. Don't slug the compressor, and then use our PT charts to calculate the subcooling, the superheat. Did I mention airflow, airflow, airflow? If the airflow is not right, nothing else matters, right? I know when universal motors, fan motors came out, guys would put those in and they wouldn't cut the shaft down or move the fan up high enough. As long as they cleared the compressor, they would keep it low. Well, there's a lot of science that goes into that shroud up there by that grill. So make sure you're getting that right. Label match everything for A2Ls, keep literature in the indoor equipment, and then use calibrated gauges. What do I mean by that? If you have a system that's running good, but your gauges look like they're a little off, typically most technicians will have a second set of gauges. If you go back and grab that second set of gauges and it's reading different, the easiest way to calibrate your gauges, a lot of people think you just go behind the mercury gauges and adjust that screw. But in reality, on our gauges, we have our pressures and we have our temperatures. Those temperatures are saturation temperature. The low side's reading the evaporator, the high side's reading the condenser, right? So saturation by definition is liquid and vapor in combination with each other. It only takes one drop of liquid with vapor to be considered saturation. Where can we find saturation? We can find it on our trucks in a tank of gas. So you can go pull any tank of gas off of your truck, set it for the refrigerant that's there, and watch what the pressure is and read ambient, whatever the ambient temperature is. You should be spot on every time. I've used that technique for years with recovery tanks. So just a fun fact on calibrating your gauges, okay? So what are we gonna use for our charge? For years and years and years, for 410A since the 90s, let's take a 3/4 inch, 3/8 line set, for example. So we have 3/4 inch on the suction side, 3/8 liquid side. We've always used the calculation of 0.660 ounces per foot beyond that, whatever the factory charges and the condenser, okay? Moving forward, if you want to know what 454B is, it's going to be fairly close to that 0.60. If someone would forget, it's not the end of the world, but if you want to really be exact about it, which most good technicians do, it's going to be a 0.55, okay? So the same application, 3/4 inch suction, 3/8 liquid, you're going to be looking at 0.60 for 410A, 0.55 for 454B. And what does that have to do? It has to do with the density of the refrigerant, right? Because R22 wasn't what 410A was. It was different. We had to understand that. Just like when you take a replacement for R22, like New 22 or Mo 99, that's a different density, and your weigh-in is totally different, okay? So just a fun fact there for you, all right? Additional support for you. You can find this little thing, this slide here, just like it is, a PDF on AHRI's website. Go there, it's in the A2L Equipment Best Practices under the A2L Safety and Handling Task Force Good Practices. So this is a nice little thing to show. Also, something they came out with that I'm sure you're all aware of by now, they have this interactive AHRI on their website. Just Google HRI A2L code map. It's that simple. This will pull up for you. Obviously, Maryland's highlighted here because they had their mouse on the Maryland, but you can touch on whatever state you're in, and it clarifies what's going on in your state, down to the municipalities, down to those local areas, counties, states, whatever, and tells you in real time what's going on in your states, what's allowed. All states are, as far as I know, correct me if I'm wrong, you can shoot me an email, shoot Chris an email, or have a qualified A2L refrigerants, but some don't have them in the code books just yet because they run on cycles every 4 years or so, okay? Last but not least, highly encourage you to go to our Opteon.com training website, okay? Opteon.com/training. Find all kinds of good stuff up there. Virtual, we're working on a lot of good stuff right now. These webinars are on there. Dr. Chuck, all good. Check up with Dr. Chuck. Is a great YouTube channel there. I think he's in his 4th or 5th season, I believe. It's in the 4th season now. Nice little less than 5-minute YouTube videos on everything I just talked about and stuff we've discussed before in prior webinars. Fun facts, and then of course we're having those chill zones on there. After these are recorded, they go live on our Opteon.com training YouTube channel. So look for those. You can get your pressure temperature charts and all kinds of good things, data sheets, anything you need, anything that you want to find out about any refrigerant, and then obviously our tech support too also, which is very impressive. All right. Hey, that's it. I want to thank you all for coming, and we'll take questions now, Chris.
Good deal. Thanks a lot, Don. I appreciate all the information. It's really a lot of information, so I'm glad that we're recording it. Let's see. We did get some questions asking about the recording and stuff like that, so I just wanted to make sure everybody hears and understands. We're going to publish all these recordings over on the YouTube channel, like Don was just talking about, but you're also going to receive an email from us thanking you for being here, right? And so in that thank you email, there's going to be a link, and click on that, and it's going to take you right to this recording. Okay, so if you are sharing it with your team, you can send that out to them or anything like that, right? So there's a couple different ways that it's coming to you. Let's see. For you, Mr. Don, we've got a great question from Dean Carlson over at Barsco. And the question is along safety, right? His question is about the 10-foot perimeter. Can you explain what they mean by that? And well, if you could, I'd also appreciate it if you also talked about up in the attic as well, because you're not going to have 10 feet away from all those rafters.
Okay, you phased out there at the end, Chris. I'm not sure if it's on my end or your end.
Oh, no worries. Let's go with Dean's question first. Can you talk about the 10-foot perimeter?
Yeah, so the 10-foot radius there is, if you don't have that 10-foot radius, because I get asked this a lot, like if you're in a mechanical room indoors or you're in a closet or something like that, they're just saying take precautions around the work area, okay? Look around you. It's recommended at this time. Moving forward, if it gets required, then we're going to have to start looking at other things. There's talk of possibly if they should make that required. Right now, it's just recommended. So I want to emphasize that it's only recommended now. So it's really about looking around you and making sure, you don't have any ignition going on. You don't, it's just really a lot of common sense. Moving forward, I heard say, I haven't seen this proven yet, but there's talk of some recovery manufacturers, the recovery machines, maybe start to put a 10-foot cord in their adapter in case this ever moves to required. At this time, it's only recommended. And quite honestly, it's not a lot different than what we've already been kind of good practice has been. You want to make sure your disconnects pulled, all the common things that you look at. Use good cords. Don't have things out there with electric tape. Just look around you. When it comes to the ventilation, things like that, that's always been good practice. When some of us had to work in small confined spaces, we usually bring a vent or an air in there. Even if you're working with the most things that are the safest refrigerants out there, you have to be aware of that. Just be aware of your surroundings. Okay.
Good deal. Thanks a lot, Don.
You're welcome.
Let's see. Well, there's that's the only question that we have in so far, but I'd like to encourage the audience, ask your question, right? If you have it and you think you might know the answer, but you're still not 100%, ask it, because the next group of folks that are also on this line, right, they may have the question or may not have thought of it yet. So feel free to toss in your questions, whatever they do come up. But Don, along the lines of that 10-foot perimeter, I imagine that's out on a rooftop or out in the backyard and back of someone's house. But up in the attic, up in a dry 120-degree attic
Yeah.
full of raptors, like what would be some safety things that we could do? What are some safety measures we could take for being up in the attics?
Yeah, that's a great question. You know, again, when I was much younger and much thinner getting up in attics, we used to work in twos, even on the hottest day. They don't do that much anymore, but you know, because attics obviously, even in Ohio where I'm at, get pretty hot. We would remove the gables or the vents on the end of the house, and we would save our old blower motors on the furnace when they were belt driven. I'm sure some of you guys my age are laughing right now or smiling because I always get that in class. We would put the cords on them and get that air moving up there. So the other thing is like, well, look for your light switches. Watch where you're standing at. Be very careful on that. Don't step on the line set. Look for leaks. Look for little observations. Be very, very. The other thing is and this is always common practice, good practices. Look for insulation, your black insulation around your suction lines. If you're up in the attic with those kind of things, check your condensation traps. You probably have some kind of safety switch up there for condensation so it doesn't run over. That's required by code. Just look for little things, slime up and stuff like that. Just check for that stuff. Obviously, your filter is always a no-brainer, but safe. And quite honestly, I'm a big fan nowadays of if you're working in an attic, work in twos. I think that's the biggest one for me. Whether that person's standing up at the scuttle hole, looking up at you, asking you if you need a tool or anything, whatever that is, just make sure you're in it and be safe as much as you can. It's always nice to have a little bit of OSB there to kneel on, you know, while you're working at. So just be careful with the A2Ls. You know, you're going to want to take extra precaution on that, even though the flammability is pretty much like for like what we're using. It's very close, let's put it that way. Close enough to where they had to make a new classification, let's put it that way. So just you know, good practices to stay focused on what you're doing.
Great, good deal. Let's see. Well, we still don't have any other questions. We do have a few more minutes left. Let's see. Don, is there anything you feel like needs to be hammered home? Something what's the most common question you get, I guess?
Yeah, so that's what I was going to ask you, Chris, if it'd be all right to ask the audience, what kind of questions are you seeing at the counter? What's the top 5 questions, or what's the biggest question that's, you know, where you feel growing pains on this A2L? You know, because the ones, I'll tell you what I'm seeing, it's the propane thing. There's propane in the refrigerant. I think we've all heard that one before. So can the tanks lay on their side? Those kind of things. What are you hearing out there at the counter? Because as a contractor, as Chris and I have talked about this before in the past, you are our knowledge as technicians. That's where we get our knowledge at. A lot of us didn't have time to, you know, because of time and money and stuff to go to training all the time. The resource at the counter was very valuable to us. So what are you seeing out there?
See, I just tossed it up in the chat bar. I'm hoping some folks can reply to the chat.
Is there a glitch with the chat?
I don't know. I don't think so.
Okay. Looks like something's coming in. Something's flashing red.
I don't know.
Okay.
Well, I guess according to the polls, they answered every question 100% right. 100% of the people responding answered it right. So this just might be the graduate class. This might be the PhD group.
Yeah. Well, listen, since we have some time, Chris, I will touch on some things that I'm hearing in the field that we're kind of putting out that myth, if you will, myth busting. So you'll be able to top the A2L refrigerants off, like 454B will be exactly like you did with 410A. Okay, there's no difference there. We're not concerned about fractionation, just like we weren't concerned about fractionation. There is a little glide in there, a little bit more than 410A, but it's not going to be a factor. Okay, it's 1 point something and then 2, and that the reason I give you a variance there, it's going to depend on whether it's in air conditioning mode or whether it's in heat pump. It'll vary slightly. Okay, some of the other factors, same POE oil when it comes to 454B, as I said earlier, and 410A. Now you will have a different POE oil for R32, and that'll be POE 46. R32 naturally runs a little warmer. Again, the tanks will be able to be laid on their side. The maximum refrigerant, we touched on this on the other webinars, is still 440 pounds maximum on the truck, and that's any type of flammability, whether it's acetylene, comes to storage in your warehouses, things like that. That's a common one. If I have one of the distributors employees sitting in the class, that flammable refrigerant area has actually been extended to a larger square footage, simply because now we're going to have more A2L refrigerants, and they're less flammable than things like acetylene. So they've actually bumped that square footage up higher than it was before. Let me see some of the other things here. Again, we talked about the 608. There's no change in that. We're going to hold it for 60 minutes. We're going to purge with nitrogen after we open that line set. Some of the things, again, we can use the existing line sets. Now we get in commercial line sets. Commercial line sets are going to be different than residential, okay? On commercial line sets, you're going to have to identify those lines. If you use existing line sets or new line sets, you have to identify them as A2L. And I don't know the exact specs on that, but it's in 15, ASHRAE 15, and it goes something like this. You'll have to mark that with some kind of a red identifier. Okay, that'll be on the line there, and to identify that's A2L, in case whatever line set is hidden, they'll identify it at the entrance of that line set, which is exposed, okay? And the same thing will go for the equipment. If you haven't seen the equipment yet, some of this isn't required, by the way. A lot of it isn't actually. So in the equipment, you're gonna see red caps on the service ports, all right? If you use locking caps, the red caps are really on the initial startup or installation to let that installer know they're dealing with something different. So when you see those red caps, you'll know you're dealing with something different, an A2L refrigerant. The other thing is on the equipment, and I can't speak for all equipment manufacturers, obviously that's not my wheelhouse, but you'll start to see more contactors with covers on them, things that we used in the past when we call them bug covers or whatever, just to remove any possibility. Again, neither one of those things were required. Just like the safety device on the new tanks, that relief, spring-loaded relief valve, that's not required. That was just an extra step. A lot of this stuff really has to do with liability. It really does. These are billion-dollar companies, as we all know, just like your distribution centers. It's all about, you know, liability. So they're just going that extra mile because we are dealing with something extra, a little different than before, even though it looks pretty close to what we're using. Good practice is going to now become required, okay? Some of the other things you'll see, obviously, the detector in the system, that detector is going to go off. I can't speak for all OEMs. The UL required it to go off at 25% or greater, 25% LFL. Until it hits LFL, it's not even flammable. So it's going to go off at 25% or greater. Some OEMs have chosen 20%. Some OEMs have chosen 15%. It depends on your manufacturer. Check with your manufacturer. And the way that works is if it senses that refrigerant, it will activate the blower, okay, and it'll run for a certain amount of time to dilute the concentration in the ductwork even less than 20 or 15%, which now makes it even less flammable because it's not even close to flammability yet. It'll run for a certain amount of time depending on the OEM, okay, and once it reads less than what that sensor is set for, a refrigerant detector, RDS is what it's called, okay, it will then go back into normal operation. Some OEMs are going to shut completely down. Some are going to just shut maybe the electric strips down if those are on, gas valves if those are on, but you have to check with your manufacturer because one size doesn't fit all. Okay, so I'll stop there, Chris, and call it a day.
Yeah, sounds really good. I appreciate it. And thanks again to everybody who's able to jump on and stick with us. Again, if you do receive these emails and there's someone in your group, someone in your company, maybe even over in a different branch, if you think that they would get value out of these monthly webinars that we're doing with Don, then forward it on over to them, right? So let's see, just wanted to say thanks again to everybody, and you'll be hearing from us in some follow-up emails.
Thanks, Chris. Thanks, everyone.
Thank you, Don. All righty.